Dear students, in this video I am going to talk about calculating the double integral, means evaluating a double integral where neither the change of variables is required, change of variables it's not required, change of order not required. Directly just we can calculate the integral, the type of situation I am talking about. There is a separate video on change of variables, there is a separate video on change of order, and the limits are already given. That type of things we are going to do. Limits not to be determined, not to be determined means limits also not required, change of variables not required, limits not required, change of order is not required. Separately videos are available when they are required. Okay, so now I'll move towards some examples, evaluate. For that concepts you can see the separate videos. Evaluate integral x is equal to 0 to 1 integral y is equal to 0 to 1 minus x dy dx. Here in this situation, this double integral to be calculated by first integration with respect to y, because y is inner integral, and that x afterwards. So this is the order. First y, then you have to go for x. This is the order, and this order should be followed because the limits are not constants. I said in earlier video that when the limits are constants, you can write it as a product of two single integral, single integral, single integral. Only in x, here whatever y terms are there, whatever y terms are there, that you separate it. This product of single integrals is possible only in case of constant limits, not in the case of variable limits. So now let me come back to this point. We are going to calculate this integral now. Solution: integral x is equal to 0 to 1, integral y is equal to 0 to 1 minus x into dy into dx. So first we have to integrate with respect to y. I will take that integral inside, and I'll say that it is y is equal to 0 to 1 minus x, and this x to be taken outside, and just dy remains. I'll change the color now. So this complete integral is inside, and outside the integral is x is equal to 0 to 1, and that x is there as it is. That x I have taken here. This integral with dy I have taken inside. So I hope you are following. Now this is equal to integral x is equal to 0 to 1. Integral dy will be y, and the limits are from 0 to 1 minus x. So x is outside as it is, and dx. So that is equal to integral x is equal to 0 to 1. So upper limit is 1 minus x, lower limit is 0. This upper limit minus lower limit substitution values is over, and outside x is there as it is, dx. So now this is equal to integral x is equal to 0 to 1, and remains is only 1 minus x. This 1 minus x I am multiplying with x, that will be x minus x square. So I will cancel this. X minus x square. Now we need to go for integration with respect to x. So it is x square by 2 minus x cube by 3, and the limits are from 0 to 1. So substituting the upper limit, that will be 1 by 2 minus 1 by 3, and then substitution of lower limit, that is 0 minus 0. That's finally 1 by 2 minus 1 by 3, that is nothing but 3 minus 2 by 6, that is 1 by 6. So this is the result. You have noted that we have followed the order. We have followed the order because there is a variable limit here. So first we have to integrate with respect to y, that comes in x. Again integration should be done with respect to x, and then constant should be substituted. So this order to be followed. Limits are given here because the limits are already given. Limits are given, order is followed. Order is followed. Suppose if, okay, I'm sorry, all order is followed. Sometimes it will not be possible for us to do it in given order. We have to change the order. That a separate video you can see. Now the same thing will be there. I'll just give a short touch of, because it's a revision video, I don't want to waste much time. In the case of a triple integral, suppose you have an integral like this, evaluate integral x is equal to 0 to 1, integral y is equal to 0 to 1 minus x, integral z is equal to 0 to 1 minus x minus y. Here some x, y, dz, dy, dx. Now you can see here that you have to follow the order because there are variable limits. So in the solution, I just write one or two steps so that you will get the idea. So integral x is equal to 0 to 1, integral y is equal to 0 to 1 minus x, integral z is equal to 0 to 1 minus x minus y, x into y, this is the integrand which I said in earlier video, dz, dy, dx. So first inner integral, inside I mean to say inner integral, this inner integral is z, after that outside is y, after that the outermost is x. So we need to go first for the innermost integral, and the innermost integral is z. So what I now do is that inside integral, I'll take with a different color now, integral z is equal to 0 to 1 minus x minus y with dz, this integral is inside, and outside the covering integrals are as it is, that x is equal to 0 to 1 and y is equal to 0 to 1 minus x. And once this yellow integral is calculated, afterwards we will multiply with x into y and do the integration first with respect to y and then with respect to x. So first of all, integral x is equal to 0 to 1, y is equal to 0 to 1 minus x as it is, and integral dz is z, and the limits are from 0 to 1 minus x minus y, x into y, dy, dx. Now proceeding in the same way here, x is equal to 0 to 1, y is equal to 0 to 1 minus x. You have to write the upper limit now, 1 minus x minus y, lower limit is minus 0, so no need. This into x into y, dy, dx. Now we will be getting x is equal to 0 to 1, y is equal to 0 to 1 minus x. We will be getting three terms now, that is xy minus x square y minus x y square, that with dy dx. Now what we do is integral x is equal to 0 to 1. We integrate now with respect to y, treating x as constant. So x is as it is, y square by 2 will come, minus x square is as it is, y square by 2 will be there, minus x is as it is, y cube by 3, and the limits are from 0 to 1 minus x. Now dy is gone because integration is over with respect to y, and dx. Now in the place of that y, you will substitute upper limit 1 minus x, after that you will substitute the lower limit to 0, and finally x is equal to 0 to 1, there will be some function of x dx, that is nothing but a single integral, and I hope you will be able to calculate the value of that one. So here let's have a short recap of what I have said, that is we are finding the double integral, where limits are given and order is followed. Why order is to be followed? Because constant limits are not there, therefore we have to follow the order, and there will be some situation where following the order will create a problem. At that time only we need to change the order, otherwise we can follow the order, given order. So given order is that inner integral is y, so first integrating with respect to y, then we will go for integration with respect to x. This value is calculated. So same concept is applied here for a triple integral, first with respect to z, then with respect to y, then with respect to x. So I hope you have understood this one. So how to find the limits? Suppose if the question appears like this, evaluate integral double integral over r sum x square plus e to the power of x dx dy, where r is the circle x square plus y square is equal to 16. Then r is the region bounded by the circle, you can write it, r is the region bounded by the circle, so this type of situation, or r is some triangle or r is some rectangle, there will be some just a symbol r given and the region is given, we have to decide the limits. So how to decide the limits of the region, that we'll see in the next video. Thank you.